All right, so problem number 9 talks about a physics class that has 40 students. So there are 40 students in a physics class. 14 are physics majors. The rest are like engineering and bioscience majors. 12 are female. And of the physics majors, 4 physics majors are female. And the question asks, if you were to randomly select a student, what would be the probability that the student will be female or a physics major? And or we start adding probabilities. And so what we want is our probability of selecting a physics major or a female or a physics major is equal to the probability of the student being a physics major plus the probability of the student being female. But if we were to look at the probability space and we were to say, hey, here's all the physics majors and here are all the female students, there's this point of overlap. There are female physics majors. And so we have to subtract the probability, and I'll just say female physics majors. And so when we have our first ORs, we're looking at this additive property, but we have to subtract the overlapping space. And so in this case, the probability of being a physics major is equal to 14 out of 40. The probability of being female in the class is equal to 12 out of 40. And the overlap probability of being a female physics major is 4 out of 40. So the total probability is going to be of the random student being a female or a physics major is 14 out of 40 plus 12 out of 40 minus 4 out of 40. Now notice I kept my denominators the same, so I could just add the numerators. So 26 minus 4, or 22 out of 40. But they want this as a probability to 3 decimal places, so I plug the 22 out of 40 into my calculator, and I get that there's a 55% chance that if I select someone in this physics class, they will either be female or a physics student. And so notice the change in our probabilities that we're talking about here. We're now starting to use OR, and we've moved from multiplication to additions.